Question 169. We have equation in implicit form. Then what is the value of derivative of y with respect to x when x is equal to 1 and y is equal to 0? So we're going to have to do implicit differentiation, right? Let's rewrite this equation. X squared plus 3y cubed is equal to 2xy plus 1. So differentiate this equation with respect to x, right? So derivative of x squared, that's 2x, plus derivative of 3y cubed, that's 9y squared, power rule, right? And times derivative of y itself, that's dy over dx, chain rule, right? Is equal to, we have 2 times xy. So leave 2 outside of the parentheses. And to find the derivative of this, we're going to have to apply the product rule. This is x times y. So derivative of x, 1, y, plus x times the derivative of y, dy over dx. And derivative of 1 is just a 0, right? So plus a 0. And we're going to have to find dy over dx when x is equal to 1 and y is equal to 0, right? Here, we can just substitute 1 for x and 0 for y. We don't have to simplify, okay? We don't have to simplify for dy over dx. Just to substitute 1 for x and 0 for y. 0, 1. Okay, so if y is a 0, all of this expression is equal to 0, right? So 2 plus 0, which is equal to 2 here, is equal to 2 times here, 0, plus 1 times the dy dx. That's just the dy dx, right? dy over dx. So dy over dx is equal to 2 divided by 2, 1. So the answer is 1. Question 172. What is the slope of the tangent line to this curve at the point pi comma 0? So this is equation in implicit form. So we're going to do implicit differentiation. So let's rewrite this equation. E to the sine y minus tangent xy plus x is equal to pi plus 1. So let's differentiate with respect to x. Okay, we have exponential function. Then that's going to be e to the sine y times derivative of sine y. Derivative of sine is cosine. And here we have y, right? So derivative of y, dy dx. Minus derivative of tangent. It's a secant square xy times derivative of xy, right? So we're going to have to apply the product rule to find the derivative of xy. So derivative of x, 1, y plus x, derivative of y, dy dx, plus derivative of x, 1, right? So that is equal to, here pi is constant. Pi is number, right? 3.1459. So that's going to be equal to 0. The derivative is equal to 0. And derivative of 1 is equal to 0. So 0 here. So far so good. Now substitute pi for x and 0 for y. Okay. So 0 here, 0 here, here 0, here pi, right? 0, pi, right? So e to the sine 0 is a 0, right? Times cosine 0 is equal to 1. So we have dy dx minus, here we have a secant square 0. Pi times 0 is a 0, right? So secant square 0 is equal to actually 1 over cosine square 0. Cosine 0 is 1. So that has to be 1, right? So 1 times, here 1 times is 0, that's a 0. So I'm not going to write it. Here we have a pi times dy over dx. So pi dy dx plus 1 is equal to 0, right? So e to the 0, that's 1. So we have dy over dx minus 1 times a pi, that's a pi dy dx. Let's say this is equal to, I'm going to move this term to the right hand side. So that's going to be negative 1, right? So we're going to factor dy dx. That's going to be 1 minus pi is equal to negative 1. So dy over dx is equal to negative 1 over 1 minus pi. Well, we can rewrite this with 1 over pi minus 1, right? Because 1 minus pi, if we switch this to pi minus 1, that is equal to negative times pi minus 1, right? So negative 1 over negative pi minus 1, that's 1 over pi minus 1. Okay? Question 176. We have a 3x squared minus 4y cubed is equal to 8. Then what is the value of a second derivative at the point 2, 1? Okay, this is the equation in implicit form. So we're going to do implicit differentiation. So 3x squared minus 4y cubed is equal to 8. So let's differentiate with respect to x. So 3x squared, that's 6x, minus 4y cubed, that's a 12y squared times derivative of y dy dx is equal to derivative of 8, constant is 0, right? Okay, so let's solve for first derivative. Here, this is our first derivative. Negative 12y squared dy dx is equal to negative 6x. So negative cancels out, divided by 6, divided by 6. So we have 2y squared, right? Here we have 2y squared. So dy over dx is equal to x over 2y squared. Now we're going to find the second derivative here. So second derivative, the notation for second derivative is this, right? Is equal to, here, this is a fraction, so we're going to apply the quotient rule, okay? Here, we have 1/2. This is actually 1/2 times x over y squared, right? So when constant is multiplied, leave this one alone and apply quotient rule for this. So denominator squared, y to the 4. Low d high, low derivative of high minus high derivative of low. So derivative of y squared 2y times dy over dx, right? So that is equal to 2y to the power of 4 y squared minus 2xy times dy over dx is x over 2y squared, right? So instead of dy dx, I'm going to write x over 2y squared. Now substitute 2 for x and 1 for y, right? So our second derivative at 2, 1 is equal to, here, I'm going to substitute 1, 1, 1, and 2 for x. 2, 2, here 1. So that's going to be 1 minus 2 times 2 times 1 times 2 over, isn't it 2 over 2? That's a 2 over 2, right? And 2 times 1 squared, which is 2. I mean 2 times 1 to the power of 4. That's 2. So that is equal to, denominator is 2. Here we have 1 minus 4, right? 1 minus 4. So that's going to be negative 3 over 2. So our second derivative at the point 2, 1 is negative 3 over 2. Question 183. At what point does the tangent to this curve is horizontal? Okay, if the tangent is horizontal to the curve, then the slope of tangent line has to be equal to 0, right? So let's find the slope of this curve, which is equal to dy over dx, right? So we're going to do the implicit differentiation. So we have a 4x squared minus 2y plus y squared plus a 16x is equal to negative 17, and differentiate with respect to x, right? So derivative of 4x squared, that's 8x, minus 2y, that's 2 times the dy over dx, plus y squared, that's 2y times derivative of y, dy dx, plus 16 is equal to 0, right? Derivative of constant is 0. Okay, so here is our slope, right? So we're gonna move this term and this term to the right hand side and factor this on the left hand side. So dy over dx, negative 2 plus 2y is equal to negative 8x minus 16. So dy over dx is equal to negative 8x minus 16 over minus 2 plus 2y. So this has to be, this is our slope of tangent to this curve. And if tangent is horizontal, like I said, this one has to be equal to 0, right? If all of this expression is equal to 0, that means numerator has to be equal to 0, not the denominator, right? So negative 8x minus 16 must be equal to 0. Then we know that x is equal to negative 2, right? And excuse me, if x is equal to negative 2, what is the value of y? We have to substitute negative 2 here, and solve this equation to find y, right? So 4 times negative 2 squared, that's a 16, minus, we have 2y plus y squared. Here, 16 times negative 2 minus 32 is equal to negative 17. So that's y squared minus 2y. Okay, here we have a 16 minus 32. That's minus negative 16. And we're going to add a plus a 17. So that's going to be plus 1, right? Is equal to 0. So far so good. So if we factor this, that's y minus 1 squared. So when x is equal to negative 2, our y is equal to 1. So the point is negative 2, 1. This is our answer. So the answer has to be A. Question 186. For what value of x is the line tangent to the curve is vertical? Okay, if the tangent line is vertical, then slope is undefined, right? So let's find the slope of this curve. We have a 4x squared minus 3xy plus 2y is equal to 1, right? The equation in implicit form. So we're going to do the implicit differentiation, differentiate with respect to x, right? So derivative of 4x squared, that's 8x minus 3 times, here derivative of this, we have to apply the product rule, right? Derivative of x, that's 1, y plus x times derivative of y, dy over dx, plus 2 times y, derivative of y is dy dx, is equal to derivative of 1 is equal to 0, right? So let's simplify this. We have 8x minus 3y minus 3x dy dx plus 2 dy dx is equal to 0, right? So we're going to factor these two, and we're going to move these two terms to the right hand side. Okay, so dy, oops, with the black, dy over dx, we have a negative 3x plus 2 is equal to, here negative 3y, that becomes a positive 3y, 8x minus 8x, right? So our dy over dx is equal to 3y minus 8x over minus 3x plus 2. So we're looking for the value of x where the line tangent is vertical, right? So this has to be undefined. This is undefined when the denominator is equal to 0, right? So when minus 3x plus 2 is equal to 0, right? So x has to be what? 3x is equal to negative 2, so x is equal to 2 over 3. So the answer is B, right? Question 188. Let f be the function defined by this. If g is equal to inverse of f and g over negative 3 is equal to 1, what is the value of g prime negative 3? Okay, remember, the derivative of inverse function, let's say we have inverse function here, and its derivative is given by 1 over f prime f inverse x, right? That's the formula, right? So here, if g is equal to f inverse, then we can write g prime x, which is equal to f inverse, is equal to 1 over f prime. Instead of this, I'm going to write g of x, right? We're trying to find g prime negative 3. So g prime negative 3 is equal to 1 over f prime g of negative 3, right? So far so good. So that is equal to 1 over f prime, here g of negative 3, that's given, that's 1, right? So f prime 1. What's f prime of x? Here fx is given right here, so derivative of the function, that's a negative 3x squared plus 6x, right? So f prime 1 is equal to negative 3, substitute 1 here, right? Negative 3 plus 6, which is equal to 3. So g prime negative 3 is equal to 1 over 3. And remember, this is the derivative of inverse of f, right? At x equal negative 3. Question 195. We have g function for x is greater than 1.5. The question is, what is the slope of tangent line to the curve g inverse at x equals 3. So let's start with the formula of the derivative of inverse function, especially g function. Okay, so here we have g inverse, and its derivative is given by 1 over g prime g inverse x, right? Okay, that's the formula. And we have to find the derivative at x equals 3, right? So we're going to substitute 3 here, 3 here. So first thing we have to do is we have to find the value of g inverse 3, this value right here, right? What is g of 3 when g function is given? G of 3 is asking us to find the value of y when x is equal to 3, right? So when x is equal to 3, it is asking to find the value of y. Is that right? What about g inverse 3? Inverse means x and y are switched, right? So this is asking when y is equal to 3, what is the value of x? That's what this value is about, right? So when y is 3, when this g of x is equal to 3, what is the value of x? So let's solve that equation to find the value of x. So we have over 2 minus x cubed plus 3, right? Okay, here we have 3 on the left hand side. On the right hand side we have 3. And we're going to multiply. Now this is a 0, right? So we're going to multiply by 2. So 0 is equal to x to the power of 4 minus 2x cubed, right? This is just a simple equation. So 0 is equal to, let's factor, x minus 2, right? So x is 0 or 2, but this g function is defined for x is greater than 1.5, right? So x has to be equal to 2, right? And this x value right here is equal to g inverse of 3, right? So we have 1 over g prime g inverse of 3, that's 2, right? Now we have to find g prime 2. Here, g of x is given by this function. Then g prime x is equal to, here, 4x cubed over 2 minus 3x squared. And the derivative of 3 is equal to 0, so we don't have to write it, right? So that's 2x cubed minus 3x squared. That's g prime of x, right? So g prime of 2, that's 2 times 2 cubed minus 3 times 2 squared is equal to 16 minus 12. So that is equal to 4, right? So our derivative of g inverse at x equal 3 is equal to 1 over 4. Question 198. If y is equal to arcsine e to the 2x, then what is the derivative of y? Okay, first we have to remember the derivative of arcsine x. So derivative of arcsine x, or we can say that's inverse sine x, right? Same thing. So that is equal to 1 over root 1 minus x squared times derivative of this. But derivative of x is equal to 1, right? So we don't have to write it, right? So that's the formula. Here we have y is equal to arcsine e to the 2x, right? So y prime is then equal to 1 over root 1 minus, if this is x, we have x squared. If this is e to the 2x, then we must have e to the 2x squared, right? And times derivative of this, right? Derivative of this by chain rule. So derivative of exponential is we have to write whole exponential expression and multiply by derivative of this, which is equal to. So let's simplify this. 2 times e to the 2x over root 1 minus 2x times 2, that's 4x, right? E to the 4x. So the answer is D. Question 204. We have function f given by this. The question is, what is the value of this limit? And if we look at this limit expression, that's a definition of the derivative of f, right? You know, h approaches 0, denominator is h. This is f of a plus h minus f of a, right? So that's actually f prime of a, but that a is pi. So f prime pi, right? So the question is to find f prime pi, and the derivative of f is given right here. So let's find the derivative of f. It's arctangent. We have to remember the formula. Derivative of arctangent is, or inverse tangent, is equal to 1 over 1 plus x squared, right? Times derivative of this x. But that's 1, so we don't have to write it, right? Okay, so f prime x is equal to 1 over 1 plus x squared. But instead of x, we have a 3x minus 2 pi, right? So all of this expression squared. 3x minus 2 pi squared times chain rule, derivative of this, right? That's 3. Okay, remember 2 pi is constant, right? Derivative of 2 pi is 0, and derivative of 3x is equal to 3, right? So that is equal to 3 over 1 plus 3x minus 2 pi squared. And we have to find f prime at x equal to pi, right? So we're going to substitute pi for x. So that is equal to 3 over 1 plus, here 3 pi minus 2 pi, that's pi, right? So pi squared. So the answer is 3 over 1 plus pi squared. Question 206. Suppose f is the function given above. Find the values of a and b for which f is differentiable at x equal 2. Okay, for the function to be differentiable at x equal 2, first it has to be continuous at x equal 2, which means when x is equal to, this function value must be equal to this function value, right? So let's set up an equation. Ax plus 1 must be equal to 4x squared plus 3b at x equal to 2, right? So I'm going to substitute 2 for x. So 2 here, 2 here. So 2a plus 1 must be equal to 4 times 2 squared, 16 plus 3b. Let's say this is number 1 equation. Okay? And also, f must be differentiable, which means the derivative from left-hand side, derivative from this function, must be equal to the derivative from right-hand side, derivative of this function at x equal 2, right? So let's write left-hand derivative. F prime from left-hand side is equal to, what derivative of this is a, right? Derivative from right-hand side, since x is greater than 2 here, f of prime x from right hand side is equal to derivative of this, 8x, right? So these two must be equal to each other. A must be equal to 8x at x equal 2, right? So if x is 2, a is equal to 16. Okay, so substitute 16 for a right over here. Then we'll be able to find the value of b, right? So 2 times 16, let me do it right over here. 2 times 16, that's 32, plus 1 is equal to 16 plus 3b. So 33, 16 plus 3b, so 17 is equal to 3b. So what's b? b is 17 over 3, right? So a is 16 and b is 17 over 3.